Hello everyone, welcome back. In part 1, we built our DIY copper pipe fan cooler from scratch. We installed the copper coil, connected the water pump, prepared the ice water circulation system, and made sure everything was leak-free. Now comes the most exciting part. Does this DIY fan cooler actually work? Can it cool a room? Is it worth building? And can it really replace a traditional air conditioner? Let's find out. Starting the system. Everything is now connected and ready for testing. First, I fill the container with cold water and plenty of ice cubes. The colder the water, the better the cooling performance. Next, I switch on the water pump. Cold water immediately begins circulating through the copper tubing. Now I turn on the fan. Air starts passing to the cold copper coil and blows toward the front of the fan. After only a few moments, the airflow already feels cooler than normal room air. This is a good sign that the system is working. Understanding how it cools. Before measuring the temperature, let's understand what's happening. Copper is one of the best materials for transferring heat. As the ice water flows through the copper pipes, the pipes become very cold. When the fan pushes warm room air across these cold pipes, some of the heat from the air transfers into the copper. The outgoing air feels cooler because some of its heat has been removed. However, unlike a real air conditioner, this system doesn't use compressor or refrigerant to continuously remove heat from a room. Instead, its cooling performance depends on how cold the circulating water remains. Temperature comparison. Now let's compare the temperatures. Before turning on the DIY cooler, I measure the room temperature. After running the system for several minutes, I take another reading directly in front of the fan. The airflow coming from the fan is noticeably cooler than before. You may also notice that the surrounding area feels more comfortable, especially if you're sitting close to the airflow. The exact temperature difference depends on several factors, including the amount of ice used, room temperature, water flow rate, fan speed, humidity levels. In cooler or less humid environments, the results are often better. Testing in a small room. Now let's test the unit inside a real room. The cooler is placed in a small bedroom or office with the doors and windows closed. After running continuously for a while, the area directly in front of the fan becomes noticeably more comfortable. This type of DIY cooler works best for personal cooling rather than cooling an entire house. If you're sitting at a desk, working in a garage, or relaxing in a small room, the airflow can make a significant difference. For large rooms, however, the cooling effect becomes much less noticeable. Electricity consumption. One advantage of this project is low electricity usage. The system only powers the fan, the small water pump. Compared to a traditional air conditioner, the power consumption is much lower. That makes this project attractive for people looking for an inexpensive personal cooling solution. However, remember that you'll still need ice to keep the water cold. If you're constantly making or buying ice, that also adds to the overall cost. Advantages. Let's talk about the benefits. One major advantage is affordability. Most of the materials are inexpensive and easy to find. The project is also portable. You can move it from one room to another whenever needed. Another advantage is simple maintenance. There are no compressors or refrigerant systems to service. It's also a fun engineering project that helps you understand heat transfer and cooling principles. Limitations. Like every DIY project, this one also has limitations. The biggest limitation is that the cooling effect depends on ice. As the ice melts, the water gradually becomes warmer. When that happens, the air coming from the fan also becomes warmer. Another limitation is cooling capacity. This setup cannot replace a real air conditioner during extremely hot weather. It works much better for personal cooling than for cooling an entire room. High humidity can also reduce the overall cooling effect. Understanding these limitations helps set realistic expectations. Maintenance tips. To keep the system working efficiently, regular maintenance is important. Replace the water after each use. Clean the container regularly to prevent algae or bacteria from growing. Inspect the copper tubing for leaks. Check that the water pump is operating correctly. Clean dust in the fan blades to maintain good airflow. These simple maintenance steps will help the cooler perform reliably. Safety tips. Safety always comes first. Never allow water to come into contact with electrical connections. Keep the pump fully submerged while operating. Inspect all hoses for leaks before each use. Keep the cooler on a flat, stable surface. If you're using extension cords, make sure they're suitable for electrical appliances. Following these precautions helps prevent accidents and extends the life of the project. So, can a copper pipe fan replace an air conditioner? The honest answer is no. A traditional air conditioner uses a refrigeration system that continuously removes heat from a room. This DIY cooler simply transfers some heat from the air into cold circulating water. However, if you're looking for an affordable personal cooling project, enjoy DIY engineering, or want a simple way to make sitting in front of a fan more comfortable, this project can be a fun and useful experiment. Just remember to keep your expectations realistic. That completes our DIY copper pipe fan cooler project. Across both parts, we've covered planning the project, building the copper coil, installing the fan, connecting the water circulation system, testing the cooling performance, measuring the results, understanding the advantages and limitations, maintenance and safety tips. If you enjoyed this project and learned something new, don't forget to like this video, subscribe to the channel, and turn on notifications for more DIY appliance projects, engineering experiments, and home repair tutorials. Thank you so much for watching. I'll see you in the next video.